Originating as subdialect of Unified Modeling Language UML, Systems Modeling Language SysML, is to system engineers what UML is to software engineers. Smaller in content and simpler to learn than UML. The current version of SysML 1.3 uses one of 9 different diagram types to represent system models and interactions. Unlike UML, which focuses on standardizing the language used to describe software systems, SysML covers a broader range of systems than can involve personnel, facilities, hardware or electrical components. What SysML does share in common with its parent language is 7 of the 9 diagram forms and the division of these diagrams into behavioral and structural types. SysML behavioral diagrams. A behavioral diagram emphasizes the steps that must happen in the system being modeled. They show step by step the interaction and options available to the various components and actors of a process. There are 4 SysML diagrams that describe the behavioral aspects of systems. Activity diagrams. Activity diagrams break a workflow down into all possible steps and show a flow of control or data. They are comprised of block, shapes and connector lines elements that have inherent rules governing behavior and actions. System engineers can use them to specify process function independent of structure without the use of partitions or swimlets. Use case diagrams. Participants in a system can have their involvement described as a series of use cases. A use case diagram presents those scenarios in their simplest form. Diagrams can be modified to show different levels of user interaction on the same system. Sequence diagrams. A sequence diagram shows messages passed between processes and systems and the order in which they given. Objects are shown consecutively with lifelines, parallel descending vertical arrows that are intersected with horizontal lines carrying messages and actions performed in sequential time. Order. State machine diagrams. System engineers use a state machine diagram to describe the state transitions of a system and what actions it performs in response to events. Possibilities for system behavior depend upon which state it's in. This diagram uses notation to illustrate initial, final, and current states, with arrows being used to denote a transition. SysML structural diagrams. Structural diagrams exhibit the components that must be present for a system or process to work. They allow objects and components to be put into classes and hierarchies with the option to add a notation that details attributes, operations and relationships within systems. The 4 structural SysML diagrams contain 3 diagrams similar to their UML counterparts, with parametric diagrams as the lone original form. Package diagrams. Package diagrams group all related objects or participants within a thematic package and examine the dependencies between them. Packages can be arranged in layers or tiers, where layers represent the logical division of components into a hierarchical class structure, while tiers denote the physical grouping of objects through their geographical location. Block definition and internal block definition diagrams. These 2 diagram styles act as a complement to each other, showing a system from a comparable level of detail, but from different perspectives. They both show the static structure of a system as a series of blocks connected via interfaces. Block definition diagrams show components only in terms of their input and output functions, disregarding the internal mechanisms that they resulted from. They also show how information and physical flows are supported using standard ports, flow ports and flow specifications. An internal block definition diagram takes a view of one of these individual blocks and describes the parts that make up its internal structure, how these parts are connected to external interfaces and each other. Parametric diagrams. A typical parametric diagram can be compared to a restricted form of internal block definition diagram. It shows the constraints of a particular block. These can be limitations on a certain performance aspect of a process and what impact this has on their interactions with other blocks. The offer a chance to identify and articulate all possible constraints and rules of a system, which make them an invaluable tool for systems engineering trade studies. Requirements diagrams. Requirements diagrams somewhat eschew the two established categories, combining both structural and behavioral elements into the information presented. They list the requirements of each model element and give definitions to the relationships arising from various states or the life cycle time scale of the system. SysML throughout industry. Using diagramming as a technique to map system processes and describe functions allows you to compare and contrast current state and possible future scenarios. Using SysML as a unified source of notation facilitates communication between other system engineers and stakeholders, creating diagrams that can be understood universally in intent and design. In terms of its application throughout industry, while UML is used almost solely to explain software system architecture, SysML can be applied across all forms of business in all its variations. Taking the automotive industry as an example, SysML diagrams can describe engine or electrical components inside the car, a sales transaction, or the procurement of spare parts and resources. It's this versatility that is so invaluable when communicating system design.